Well, I have come to a point where I've started using Enscape inside Sketchup. I did a video just to share my excitement about that move. I've been exposed to a lot of other renderers, especially inside of Sketchup. Thea was my one go-to. I didn't particularly enjoy V-Ray that much inside Sketchup. And then also Octane, I use that as a standard renderer with Cinema 4D, but inside SketchUp, it doesn't kind of gel very nicely. The one I've settled on is Enscape, and I'm very excited about where that product's going to. But I thought I'd put together just a little bit of insights into certain things that help one to get to photorealism. Now, photorealism happens when you actually render it out, so it's also dependent on the render engine that you're doing. But pretty much most people will tell you that if you've got proper lighting and proper textures or proper materials, you're 90% of the way there. What they don't cover is context. And that's something I just want to briefly highlight with you using a few examples and not getting into creating a massive model, just showing you the finer detail of what I mean by context. And then I'll do another video on materials and the importance of certain aspects, and then lighting. This is a starting off level for people who are getting into SketchUp and wanting to do good renders. It's by no means a concise, A to Z of creating photorealism. So see it for what it is, and maybe if you've been rendering for a while, you might have overlooked some of this stuff. So I've got a little acronym CML, which stands for context, materials, and lighting. And I think those are the three key areas when creating photorealism in any CAD model that you're building. Okay, so let's get into, like I said, I'm using SketchUp and Enscape as a renderer. And we're going to be talking about context. And hopefully these things get to help you along the way. Okay, so there's three things we're going to talk about, which is size, it is shape, and surface. And I'll explain what I mean by that. So often when I started designing in SketchUp, I would just draw a model and not worry about size. Cinema 4D is about the same thing. You just pull out a block and you start to model, and you don't worry about the actual dimensions. But now when you're coming to rendering, the renderers today depend on physical size. So if you're creating a room, let's say we're looking at these three rooms. If you're creating a room that small size or this size or this size, and you're using the same lights inside of it, they're going to react totally differently. But what tends to happen is if you put a light in a bigger room and it's not working that well, you will tend to just add 10 times the power of the light to light the room up. But then that is 10 times the power of the light onto the materials that you have in the model, and then you start to lose a lot of photorealism. So from the word get-go, I would suggest, instead of going the route that most people have gone, that I've also gone for a long while, where you're just drawing an sort of arbitrary figure, rather do it according to measurements. So if I draw a room now, if I want to draw a room, I'll go there and I'll type in 3 meters, say by 3 meters. And you can see that in context, that is a 3 by 3 meter area. Because if I drop a light in there and I add a ISE profile, the actual profile that manufacturers put into their lights, it will work effectively because it's designed to light up a room of say 9 square meters or a room of 20 square meters. There's certain parameters built into these lights. So if you put a light with a certain power into a size room and you put it into a bigger room, it's going to have total different effect. And for me, when I used to work, I used to kind of drop the light into the room. Let's look at this, for example, see what this thing size is. This thing is 10 meters, okay? This one here is, what's it? 2.5 meters. This one here, the length is 37 meters. But if you had to just drop in and you had no perspective, you'd had no relevance, no context to size. In this case, we're using measurement as our context. If you're using measurement as your context, then you pretty much have to realize this is massive. This is going to be like a shopping center. So you're going to need tons of lights in this area to light up the area. You can't put in one light and expect it to do the same as the rest. So for example, let me show you. I'm going to take you into the first house, then the second house, and the third one using the exact same light. Okay, so it's an Omni light with the same power. I'm not changing anything. And then we move finally into this big property or this big room with the same light, and you'll see the effect that it has. Okay, so if you were confused every time you built a different room and put a light in and you find it didn't light it up as it did the other room you did, it might be that your scale is totally out of sync. So let me go into the first room, and I am just going to pull up actually I should have started this already. I'm going to start up Enscape. Enscape, if you don't know about it, if you haven't used it, it is incredible, and it's got a bright future. They've got a 15-day trial on enscape3d.com. Download that, check it out, and maybe it's the tool that you want to get started using. Okay, so this is in that first room. That's the amount of light that it gives in this first size room, which is pretty much, I think I measured it as 10 meters. But I am going to drop the sun away here now. So in Enscape, while I'm in the render window, I can keep shift down, right mouse button, and just drag the mouse across the screen to move the sun across the sky, and we'll take it right down into the night. Okay, it's actually indicating, if you look at the bottom here, it's actually like 3 o'clock in the morning, but it's totally dark. So this is the first one. We've used this light with power X, whatever power it was, and that's the look we have. That's the amount of lighting it gives. Okay, let's shift around, and we're going to go now to the second, the medium size room, with the same, exactly the same light, power, everything in there. The room is just half the size. And let's see, we need to refresh this. Let's go back in there. There we go. And let's drop the sun also right down to nighttime. Okay, now we're able to see this being lots more illuminated. The very same light, half size of the actual room, we're seeing lots more illumination. Now if you use this light and build a room this size, you'd get this lighting immediately if you were creating a model. And the light would reflect and bounce off the walls more effectively. It's not just an arbitrary light. This light understands that it's supposed to have a fall off in a certain distance. There's the inverse square rules and all that sort of stuff that it's working with. Okay, so let's get to the third one, which is the smallest room, and see what we have there. Let's refresh this. There we go. Now we are in, let's click on scene 3. This one I showed you was 10 by 10. Then I sized it down to half of that, and this is half of the medium size room. Can you see the amount of light it creates? So if you are building something into a room that is not proportionate for the light you're putting in, pushing up the power of the light is not going to only it's not going to be the only solution, because if you push up the power, you could blow out the textures on certain areas. And the lights are designed to actually illuminate in a specific way. It's very scientific in how it works. Renderers today are very intelligent. They're based on physical properties that exist. So let us go to the final scene, which is the big property. Okay, so this is the massive property that we're going to do with the same light. Let's see what we have. Pretty much here, if you look on top, I'm not sure if you can even see, there's a little faint little dot here where my cursor is, and a little one there, if I can imagine. That light that lit up the small room so bright does absolutely nothing over here. And that's the point I'm trying to make, is you might build a big building like this and say, but the light worked in the other room, other design I did, it illuminated the whole area. Now this doesn't work. Then go back to your size, go back to your scale, and maybe the model that you've created is 20 times the actual size it should be. So then get it down to be a more realistic, and the light would work better in that. Same thing with materials and so forth. So when I do the video on materials and lighting, we'll probably cover a few of these areas again. So just remember, key point with realistic renders is the size of the model you're working with. Because if the size is out, then the materials and the lighting are not going to gel very well with it. Okay, the next point I wanted to highlight is shape. Now, often when we look at shapes in life, every single edge that we look at is rounded. You do not get a 90-degree edge that's got a perfect sharp 90 degrees. It doesn't exist in nature. So the eye is used to seeing edges as being round. Even a blade, as sharp as it is, has a rounded edge if you go down to the microscopic level. So it's crucial that areas that you're going to be focusing on in your actual renders, that you make sure that the edges are rounded. Some render engines do that automatically at render time. Other cases, you've got to do that on the physical model. Sometimes it's not totally practical, because if you try and round off every single edge, you're going to be beveling and smoothing all edges on massive models, and then it becomes a bit overtaxing. Sketchup has some edge rounding, beveling things, but they're not that totally effective. The point I want to get to is actually show you why it's important to round off edges, and I'm doing an over-exaggeration here. You can see I've actually done a sharp cut on here, and here I'm doing a smooth round corner. But if we look at the render itself, let's just see if we refresh this. If we look at the render, there, if I take this maybe at this level, and I'm just going to move the sun around so we can get a bit more contrast from the areas. Okay. But if I look at this here now, let me take it at this point. If I look at this line here, if we had an edge that was square on that sharp angles, the shadow would fall on this surface, a different shadow here and a different shadow here. Whereas if we look at this object, which has got a rounded corner, and I know it's over accentuated for the purpose now, but can you see how soft the shadow is here? And the eye believes this much more than it's going to believe that particular structure. Let's just do something which I didn't contemplate doing, but I'm going to do this and this. And I'm not sure if these bevels work well with Enscape, if Enscape picks it up well. But let me just click this and maybe do a 0.05. Okay, so it's going to bevel these edges, and we just see if it has any other result with it. Okay, let's say we're going to accept that, and we go to scene 7. Or maybe let me just navigate a little bit better around, and let's check the render out now. Okay, I've got to probably send a refresh. What do we do? Okay, there we go. Okay. So there, it's softening up those edges there. So the eye, the human eye, will look at it, and in the greater scheme of things, when we're modeling, when it sees the edge, then I've over rounded off that edge. But when we see a slight edge on there, and it's not this extremely, you can look at this here, this is so sharp, the eye is wondering if it's fake between the two. If we just had to round off that slightly, the eye would believe that that is possible, that that is a natural shape. So important to note the shape, and probably in SketchUp it's more challenging to do it than in something like Cinema 4D, where you could soften the edges and do it with a whole lot of polygons and bevel edges and keep it nice and smooth. But just to be aware of the importance of the shape of your edges when it comes to realistic rendering. If something's not looking kind of right and it's too sharp, then you know, possibly just do something to the edge to soften it, and the eye will accept it better. Third thing is the surface. Now I'm going to just possibly do maybe a little bit more of an aggressive one here. What we mean by surface is sometimes you have a surface and the person will put a picture onto it, and it will be sufficient if you're at a distance looking at that picture, say of a cupboard door, and it kind of looks okay. But when you move the light, there's no surface that's either forward or back that can actually create shadows, and then the realism goes out of the window. So it is important to consider the surface, that if you're wanting to create that sense of depth, so that when light strikes it, there's a shadow, there's a contrast, that adds a lot to photorealism. And I'm going to just look at the renderer. Let's go again with, this thing doesn't refresh all the while I'm running this screen recording, but let's look here. Can you see that? There's automatically more believability on the same thing because of a shadow cast. So if you want to create a setup where you want to show that there is a definition of the area, dropping it in or pulling it out is essential to creating the photorealism. So if you're working with, unless there's no offset on the object itself, then that's a different matter. But if you're creating a cupboard door or something like that, don't leave it as just a cutout area of a different color. Create some sort of intrusion or extrusion to make it look. So let me just show you. I've set up a scene here that might explain this a little bit better. If we look at this is now with a little ridge area, but this makes things a bit more believable when you're looking at it. You can see that there's an object that's up here. But let's take it to the next level and just round it off with this here. Here, for example, you have a cupboard. And if we look at the render of this cupboard, immediately you're starting to look at this and you think, this looks a bit weird. Maybe I should just keep the colors constantly so that we can compare apples with apples here. There we go. Let's see everything looking the same. Okay, so in this case here, there's no extrusion of objects. Say this was a cupboard and we just put handles on here. We could put on, let me just do that. I'm going to just do it on this side here. Put a little round handle. Okay, and we're going to just color it some other color. Okay, on this side, I'm not going to even put a different color. What I'm going to do is just keep the same color, and I'm just going to create an extruded knob with it. I'm overemphasizing the extrusion, but it's to show you in 3D world, it's not good enough to have a image, and this will translate into when you're using materials also in the next video that I do. When you're using materials, you obtain this kind of illusion by using bump maps, normal maps, displacement maps to create the sense of depth of shadow so that it becomes more believable to the eye. So if we look at these two objects here now, pretty much it's got the same elements. It's got a top over here. It's okay. This one is now an intrusion here, which I'm not going to do here because the purpose of this exercise is the one object doesn't have any surfaces that are proud or recessed at all. It's just flat, but it's got the same sort of color features. And this one does have it, and you'll see the difference in the believability. So if you look at this here, somebody looking at this side is going to go, okay, there's supposed to be some sort of door here with a knob on, but there's no depth to it. There's no aspect to it. The reason for that is because there's absolutely no shadows that are being cast. There's a light coming on, but it's not casting any shadow because there's no offset or recess for the 3D model to cast the shadow. Okay, if you're used to working in 2D, you might get away with this, but with 3D, you need to give the renderer the option to bounce the light to create shadows, because that's what the whole visualization is about. It's creating a photo is known just for the fact of its ability to capture light and dark, contrast areas, and that sort of thing. So if we look at this model here, we literally can believe this a bit more because these shadows here are all created from the fact that there is a recess in here, that this area, if we look closer to it, I haven't changed that color there, but anyhow, if we even look at the top of this model here, we're having a bit of reflection of the yellow here. That all adds to the believability. Now this is coming in on the texture side. I'm moving into what the next video should be about. But just to show that if you're creating a cupboard, instead of just doing a cupboard and drawing a colored door like that, pull it out a little bit. And I'll show you even if I push this door here, even if I push it back quite a bit. Let me just take this and push it back. Or even if I take it a little bit in there, let me just push it, recess it in there, you'll see. It's still believable because there is a bit of drop shadow there and a bit of contrast to show that it belongs. Okay, if I pull it out and I pull it out just a little bit, not even as much as we had it before, if we look at it there is still that believability on the edge of that cupboard. Okay, So the point I get to is make sure that if you want to create the photorealism, be aware of this surface contrast between themselves. And then the last thing, look here, something that we might not even notice. I did a little groove in here by just moving it back, and then it creates a darkened shadow area here. Okay, it's cut right through the top here, but it's just done as a purpose to show you that creating that separation also adds to the realism. And all that is a section of the surface that's pulled away. So it's sections pushed away, sections pulled towards you, creates the actual structure and enough depth or enough extrusion for light to bounce on it and create realistic shadows, hence more believability, hence you get closer to photorealism. Okay, so this model is not anywhere near close to photorealism. It's the principle of the surface, moderating the surfaces as you're working with it. The next video I do, I'm going to talk a little bit about some sort of high-level hints on the texturing, and then we'll talk about lighting also. I might decide to do the texturing and lighting together because they kind of work hand in hand. So I probably will just do one on that. So hopefully this has been of help to you, and you'll be able to take some of these aspects and put it into your modeling and your rendering. Okay, so have a fantastic day and God bless.